Welcome back to Future Trends, where we dive into the innovation shaping tomorrow's world. This is Tech Tomorrow, your weekly guide to cutting-edge technology. Today, we're exploring the future of autonomous vehicles. If you're fascinated by the tech driving change on our roads, be sure to subscribe and hit the bell icon for more insights. Have you ever wondered what the future of transportation might look like? Imagine a world where you can read a book, watch a movie, or even take a nap while your car drives itself. This isn't a far-off dream. It's the reality we're fast approaching with autonomous vehicles. These self-driving cars are equipped with advanced technology that allows them to navigate without human input. Using a combination of sensors, artificial intelligence, and machine learning, these vehicles interpret their surroundings, make decisions, and operate safely on our roads. The potential of autonomous vehicles is transformative. They promise to revolutionize transportation by making it safer, more efficient, and more accessible. Picture fewer traffic accidents, less congestion, and increased mobility for those struggling with traditional driving. So buckle up as we delve into the fascinating world of self-driving cars. Autonomous vehicles, once a concept of science fiction, are rapidly becoming a reality. To better understand where we stand today, let's explore the different levels of autonomy. It all starts with level 0, where the human driver is in full control. At level 1, we see some assistance, like cruise control, but the driver still handles most tasks. Things start to get interesting at level 2. At level 2, the vehicle can control both steering and acceleration-deceleration under certain conditions, though it still requires constant human supervision. Level 3 introduces conditional automation. The car can manage all aspects of driving in specific scenarios, but the driver must be ready to take over if necessary. Level 4, or high automation, means the vehicle can handle all driving tasks in certain conditions without any human intervention. Finally, Level 5 represents full autonomy. The car is capable of performing all tasks under all conditions without the need for a human driver. Most of today's self-driving cars operate at level 2 or 3, where the vehicle can manage some tasks but still requires driver oversight. The technology behind autonomous vehicles is complex and fascinating, akin to a symphony where each instrument plays its part to create a harmonious output. In this case, that output is a vehicle capable of independent navigation, making real-time decisions on the road. The primary instruments in this symphony are the sensors, LiDAR, radar, and cameras. These sensors act as the vehicle's eyes and ears, providing a 360-degree view of the environment. LiDAR uses light pulses to measure distances and detect obstacles, while radar uses radio waves to identify objects, their speed, and direction, even in poor visibility. Cameras capture visual data, recognizing traffic signals, road signs, and other critical information. But having eyes and ears isn't enough. The vehicle needs a brain to interpret the data. This is where artificial intelligence, AI, steps in. AI algorithms analyze the sensor data, creating a detailed map of the environment. This map is then used to plot a path, anticipate the actions of other road users, and make decisions. These AI algorithms are trained using machine learning, where they are fed vast amounts of data from real-world driving scenarios. This training helps the system recognize patterns and make informed decisions, from staying in a lane to overtaking a slow-moving vehicle or responding to an emergency. Autonomous vehicles also utilize a technique known as sensor fusion, where data from different sensors is combined for a more accurate understanding of the environment. For example, LiDAR might detect an object ahead, the camera can identify it as a pedestrian or another vehicle, and radar can determine its speed and direction. These systems work together to detect obstacles, interpret traffic signals, and make real-time decisions on the road. It's a marvel of modern technology, bringing us closer to a future where autonomous vehicles are an everyday reality. Autonomous vehicles are poised to have a wide-ranging impact on various industries. The potential for transformation is immense, and we're already seeing the early signs of this shift. Let's explore how this technology could reshape the world as we know it. Consider the ride-sharing industry. Companies like Uber and Lyft are conducting ongoing autonomous vehicle trials, promising safer and more efficient services that could redefine urban transportation. Imagine hailing a ride on your smartphone and a self-driving car arrives, ready to whisk you to your destination. No small talk, no detours, just a safe and efficient journey. Then there's the logistics industry, where autonomous trucks could revolutionize freight transport. Long-haul trucking is demanding, with strict regulations around driving hours to ensure safety. Autonomous trucks could operate nearly 24/7, pausing only for refueling and maintenance. This could dramatically reduce delivery times, making supply chains faster and more efficient. Beyond speed, autonomous trucks could also bring down costs. Eliminating the need for a driver would save companies significantly on wages. Additionally, autonomous vehicles are designed to operate optimally, reducing fuel consumption and wear and tear, which could lead to further savings. Beyond these industries, autonomous vehicles could pave the way for entirely new business models. Think robotaxis, autonomous delivery services, or mobile businesses operating out of self-driving vehicles. The possibilities are vast and exciting. However, it's important to remember that this transformation won't happen overnight. Autonomous vehicles are still in their early stages, and it will take time for the technology to mature and for regulations to catch up. But the potential is there, and it's growing every day. Imagine a city where cars, traffic systems, and pedestrians communicate seamlessly. This isn't the plot of a sci-fi movie, but the vision of future smart cities, where autonomous vehicles play a central role. In these smart cities, autonomous vehicles won't exist in isolation. They'll be part of a connected ecosystem, communicating with each other and with the city's infrastructure. Traffic lights, road signs, and even parking spaces will be digitized, transforming our streets into an intelligent network. This integration of autonomous vehicles into smart cities will have profound implications for traffic management. Today, traffic congestion is a major challenge, costing economies billions of dollars each year. However, with autonomous vehicles communicating with each other and the traffic system, they can coordinate their movements to optimize traffic flow. This means fewer traffic jams, shorter travel times, and happier commuters. But the benefits of autonomous vehicles in smart cities extend beyond traffic management. They also promise to enhance urban mobility. Autonomous vehicles could make transportation more accessible for everyone, including those who cannot drive due to age or disability. They could also solve the last-mile problem in public transport, ferrying passengers between transit stations and their homes. Moreover, autonomous vehicles can contribute to greener cities. Self-driving cars can optimize routes and driving patterns to reduce fuel consumption and emissions. When combined with electric powertrains, they could significantly lower the carbon footprint of urban transport. For these benefits to be realized, we need more than just technological advancements. We need regulatory support, infrastructure investment, and public acceptance. The journey toward autonomous vehicles in smart cities is a collective one, requiring collaboration among policymakers, technologists, city planners, and the public. However, the road to full autonomy is not without challenges. Beyond technical hurdles, there are significant ethical conundrums. For example, how should an autonomous vehicle make decisions in the event of an unavoidable accident? Who should it prioritize? The passenger, other drivers, or pedestrians? Such questions spark heated debates. Regulatory hurdles also pose challenges. Autonomous vehicles must comply with safety standards. But what happens when a self-driving car causes an accident? Who is held liable? The manufacturer, software developer, or owner? And let's not forget the technical challenges. From ensuring foolproof object detection to overcoming the limitations of AI, in unpredictable driving conditions, engineers and developers have their work cut out for them. These challenges need to be addressed before we see widespread adoption. In summary, the future of autonomous vehicles holds immense potential. We've explored the fascinating realm of self-driving cars, from their classification into levels of autonomy to the intricate technology that powers them. We've seen how they're poised to revolutionize transportation, making it safer, more efficient, and more accessible. These vehicles won't just transform our roads, but also our cities, integrating into connected infrastructure for seamless communication and improved urban mobility. The ripple effects will be felt across industries, from ride-sharing to logistics, promising safer services and cost-efficient solutions. Yet, this promising journey isn't without its speed bumps. Ethical dilemmas and regulatory hurdles pose significant challenges that need to be surmounted for us to fully embrace this autonomous future. But with each passing day, we're moving closer to a world where self-driving cars are a common sight, not a novelty. Until next time, stay curious and keep exploring the world of tech.